Hello everyone. In this video we're going to cover the idea of pointers and how they can point to arrays. So we're going to go with creating a file called point to array. And I'll create, let's see, just a float array. I'll say float, I'll call it t, and I don't know, we'll give it a few values, 0.6, 1.4, I don't know, 3.9. Okay, so we have an array of floating point numbers, just 3. Here we're going to keep it simple. Why don't we do an address analysis, right? Similar to how we did one for character pointers, we'll do one with this floating point array. So here I'm having 3 print statements, or there's 3 variables that I want to print. I want to print the address of t, meaning the value that's stored there. I'm going to print the address of t, right? So I'm printing t, and the value that it contains is a pointer. I'm going to print the address of t, and then I'm going to print the address of the first element of t. So let's see what kind of response we get from this program. So it looks to me that they're all the same. So it's the same thing when I make a character array, how the string itself, when it's an array, all the addresses, meaning the name of the variable itself, the address of the variable, and then the address of the first element, they all point to the same address. Usually when you go about accessing an array, well, the first element is t of 0, right? So it looks like it all points to the first element of the array. So when we go about accessing arrays, what we do is that we use something called subscripting, meaning that we're going to use the square bracket and we're going to provide it a number. And that number is going to be kind of like the offset. So 0 is the first element of the array, 1 is going to be the second element, right? 2 is the third, etc., etc. So one way, the traditional way of going about printing values of the array is this, where we access the value that we want by, again, using that same square bracket and giving the index that we want to access. So here in this print statement, I'm accessing the first element of the array by using t0, the second element of the array by using t1, and the third element by using 2. Well, if I wanted to print these same 3 values using pointer nomenclature, here's how I would do it. So the first, when I want to access t0, I'm just going to dereference t. And why does that make sense? Well, that's because t is equal to the address of t, which is equal to the address of t0. And because the beginning of the array is index 0, and since the array starts at that same index, that same memory location as that index, I can just dereference t. So what am I doing in the subsequent lines here? Well, here I'm adding 1 to the address of t, and then I'm dereferencing it. And then I'm adding 2 to the original address of t, and I'm dereferencing that. So why don't we see the result? It's pretty wild. We have the exact same result. So, right, and this is actually what's happening under the hood. In line 9, when you're doing the subscripting with the square brackets and the index that you want to access, this is what you're really doing. You're providing an offset to the address of data that you want to access. So this, in theory, I can say is this, right? So the corresponding index that I use for the array, I can add it to the address of the array to get the value there. It's a pretty wicked way of accessing pointers. And these two, they're equivalent. What I'm trying to say here is this statement right here, that when I do a when I add 0 to t here and then dereference it, this is the equivalent of accessing the 0th index of t. And then when I add 1 and then I dereference that address, well, that's the same as accessing t at index 1. And so on. So this isn't exactly too applicable, but here is another way of seeing, programmers access arrays like this. And sometimes you want to do that in case you're dealing with a pointer, in case you have a pointer. So this is just another way of accessing the memory. This is a little bit more dangerous because it seems that you're more inclined to go out of bounds and to access what's there. And because it's dereferencing it as a pointer to a float, if I try to access some values, let's say I do t plus 3, there might be an integer there, or a double, or a character, or something else. If I add enough stuff, hell, we can even have a pointer to a function there, right? And we could be dereferencing a function and trying to print a floating point number. All right, and that can cause some havoc. I mean, you can do the same thing with subscripting, like on line 7. However, I mean, this is just another alternative way, another alternative tool for accessing pointers. And what's really, really neat is that you can create a loop like this. We have here a pointer to a float and an integer I. Here we create a for loop that has two starting conditions, those two starting conditions being f equals t and I is equal to 0. Then we have a stopping condition, so while I is less than 3, and then we have two step conditions where f is incrementing by 1 and I is also incrementing by 1. So why don't we see the result of the program? Turns out there's an error there. Because I was adding I was actually incrementing the offset by 2. So now we have the true results, right? So here I have 0.6, which belongs to the 0th index, and I went to 0.9, right? Because f incremented by 1, which means it was here, but because I added another 1, meaning I, it printed this, and then we got some junk here. But thank God it didn't result in a segmentation fault. But now this is completely correct, right? F is able to move as it does, and I mean, here's just another way of using pointers to access arrays. This relationship is a bit, it seems particular and peculiar now, but I assure you, if you get to, I mean, the more you deal with pointers and how they work, and the more you just get intimate with them and program with them, you figure out tricks like this. And sometimes it makes your life easier, sometimes it makes it more difficult. But this is just really another tool in the toolbox for you to use. This is also very good for understanding some concepts in C++, because while here we have f is equal to t, right? And we're using a counter I, and we're incrementing f by 1 each time. It looks like if you have some ending pointer, you can actually do something like this. Well, let's put on the same line. We can do something like this. We can get rid of I. We can say f does not equal f end. We can do something like this, right? And it'll work the same way. But this is a little bit more complicated, because here f gets the beginning of t, and since we can only go from t plus 0 to t plus 2 because that's the size of the array, I say f end is equal to t plus 3 because that's 1 plus the recognizable data that belongs to f. So while this pointer, this address does not equal this address, we're going to keep going, and we increment it from here. So this is a little bit more complicated, but this is how some things are done in C++ when we're interacting with pointers. But this will be saved more for when we get there. In the next video, we're going to talk about a pretty crazy concept called void pointers. Thanks.